Hello friends. Welcome to Unacademy. Crack Gate Computer Science with us, top educators, quality content, great learning experience. Let's crack Gate CSE. Our anthem is Crack Gate and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded courses from India's topmost educators. About myself, Srinivasarao IS, having 17 years of GATE experience as an educator with the subjects of DBMS, computer networks, and operating system. I also had industry experience as a database admin and a system admin. Also had certifications like DBA, Cisco, MCSA, and Red Hat Linux. Throughout my journey of GATE as an educator, taught in many premium academies like GATE Forum, the GATE Academy, Vishwa Educate, including Made Easy too. Also had a participation to motivate the students and encourage the students, and many of the single and double digit ranks. If you get subscribed, what will you get? You're going to get daily live classes and live tests and quizzes. Mock tests are playing a very important role to crack any kind of competitive examination. Using daily live classes, you can chat with the faculty and get clear all your doubts. And there are structured courses are available as per the curriculum of respective competitive examination. You will be given unlimited access. You can access everything, whatever is available in respect to portfolio. So once you get the subscription, then you will be given live classes as well as recorded classes. As far as GATE and ESE concerned, there are many courses are available in CSIT. You can view them and learn the content from topmost educators. There are two kinds of subscription, 12 months and the 24-month subscription. Apply my promo code Sankara to get 10% off. So therefore, you will get it for 22,500. The other subscription is 24-month. After applying my promo code, you're going to get it for 27,000. So 2 years subscription is preferable to crack GATE examination. And this is a schedule I am providing to teach or to give you complete DBMS lectures which are running on YouTube, and special classes are running on Unacademy student learning app. There we will discuss PCQs and MYQs. So as far as today's lecture concerned, we are going to learn about schema design, that is nothing but part 6. So what is today's lecture? Today's lecture is mainly talking about redundancy. Redundancy, duplications. They're all synonyms only. How the redundancy is going to cause the problems in real time, and what are the issues with the redundancy. If we have redundancy, how to avoid them. Obviously, we would like to see that non-redundant database. Non-redundant database we would like to see in real time. If at all you have redundant of data, then how to eliminate it. The elimination also you will learn in this lecture. Before you get it eliminate, we observe that some of the problems which are coming with redundancy, just I kept it as issues of redundancy, and what are the reasons why the redundancy is coming. Why are you going to get the duplication of data in the tables? We will observe in this session. The motto of this session is nothing but what is the redundancy, the causes, what are the reasons to generate the redundancy, and if you have redundant data, what are the issues of them in real time with the database design. Then if you have redundancy, how to eliminate it. So what is a redundancy? When you talk the redundancy of data, it is nothing but duplication of data only. So you will get duplication of data which is stored at different locations. So if you find duplicity in your respective databases or tables, then we will understand that it is redundancy only. So what are the types of redundancy we have? We have different types of redundancies. You can say that individual attributes, you may find the redundancy. That means the columns, you will get the redundancy, or tuples, you will find the redundancy, or you say table, you will get the redundancy, or you say file, you will get the redundancy. So what is the attribute redundancy? So within the attribute, you will get the redundancy. What is the tuple level redundancy? Entire tuple is going to be duplicated. So what is the table level redundancy? Entire table consists of redundancy. What is a file level redundancy? A file consists of duplicity of records. Is very dangerous. The table level redundancy and file level redundancy. I will show you here what is attribute level redundancy. When you talk attribute level, you say there is a R and the column is A. I am finding same number of tuples. And what is the tuple level? When you talk tuple level redundancy, entire tuple you may have duplicity. For example of this, if I'm talking like this, there is a relation R which consists of A and B. I'm having A1 and B1. Once again, I'm having A1 and B1. Once again, I'm having A1 and B1. So this is a tuple 1. You first tuple is unique, second tuple is a duplicate, and third tuple is a duplicate. Hence, we will call them, they are what? Redundant. So when you have duplicity of data in every tuple, it is called as tuple level redundancy. This is called as attribute level redundancy. What is the table level? Obviously, the entire table you may find the duplicity of data, that is table level redundancy. Okay, friends. Now let us see types of redundancies. As it spoke here, file level is nothing but file have duplicate records. It's a highly difficult to identify duplicate records at a file level. File have duplicate records. And what is a tuple level? You say that every tuple has a duplicates. Attribute level, attribute has duplicates. So table level is a superset of your tuple set and attribute set. You can say that table has redundancy. Now we will observe why the redundancy is coming. The redundancy is coming due to two important factors. One is the functional dependency, the other one multi-value dependency. These are the two factors which are creating redundancy in the table. So we are not going to keep anything wantedly redundancy, but if the functional dependency is satisfied, then there may be a chance of what? Redundancy. So two important factors which are generating the redundancy is functional dependency and multi-valued dependency. Let me prove here. I'm saying student number implies student name. Now there is a student column. I am writing here student number and a student name here. I want to prove this functional dependency. Look at friends. I am saying S1, name is X. When I repeat S1 again, you will get X again. When I call S1 again, you will get X again. Therefore, what do we understand? The functional dependency is one of the factors to produce or generate duplicity of data, because as the rules of functional dependency, whenever LHS is repeated, then RHS value is supposed to be repeated. Then we understand this row is duplicated and this tuple is duplicated, and overall table has got duplicity of data. So functional dependency produce redundancy of data. Hence, in order to avoid redundancy, what do we do? To avoid redundancy, what do? We will identify LHS as a key. This is the very important rule. That means if LHS is a key, then we are unable to produce, or a table cannot generate itself duplicity of data. So let us avoid this redundancy using this example. I am saying student number implies a student name, and I am saying like this, the student number and the student name. Now I am saying that student number is going to deal as a key, candidate key or primary key or unique key, whatever it may be. If I am saying S1, X is the data. If I am trying to enter S1, it will not allow you to enter duplicity of data. So friends, it's very clear to identify functional dependency is one of the major factor for the generation of the redundancy in the table automatically. So you want to stop the redundancy, the factor or the condition is nothing but if you make the left hand side column as a key, then you could able to control redundancy of the data. But obviously LHS cannot be key in all the cases. Therefore, functional dependency is following us to provide or generate redundancy. So how to avoid this redundancy, we will look at in the next pages. That is, the redundancy which is coming from functional dependency can be cleared by using the concept of decomposition or by using the concept of normalization. So normalization will help us. It is a step-by-step process to avoid the redundancy which are generating in the given relations. So finally, we want to see that non-redundant database. So therefore, the functional dependencies which are generating redundancy can be controlled 100% after reaching to one level of normal forms. Okay, friends. So the other reason is multi-valued dependency. So what is a multi-value dependency? Observe, friends. If I am saying there is a relation R which consists of A, B and C, I am saying in order to avoid the redundancy, I am making A as a primary key. When I am making A as a primary key, then you see, friends, the duplicity is not possible in attribute A as it is defined with primary key. And I am saying here C is a multi-value. Please observe carefully. Now I am raising one another important terminology, multi-valued attributes. Now I am also saying B is also multi-valued attribute. Therefore, what happened? You can enter duplicity of data in this. So how? I am saying A1, B1 and B2 and C1 and C2. So it has got the provision to enter the multiple values as B and C are the multiplicative nature. So pair of values I can able to enter into B and C, but it is not in A. A is a single valued column, and that too it is identified as a primary key. So therefore, by splitting this, you will understand like this. A and B and C, three columns are there in the relation R, and the values how I am presenting. Look at friends. A1 can come with the B1. So A1, B1, and this B1 can have two combinations C1 and C2. So I am also writing here C1 combination. Again repeat, A1 with B1, you are generating C2 here. Okay friends, and one more, this time I am going to take the combination of B2 here. Again A1, B2 is coming. One time it is manipulating with the C1 and A1 here, B2 here. It is going to map with the C2 there. Friends, what I did, I just converted your multi-values into single values. Please observe what I did. I converted your multi-values into single values. Friends, so I can write one important term here. What is that? If you leave your table R, then I can confirm it is not in 1NF because of what? Multi-values. But here, after conversion into your single values, I can confirm your R is in first normal form. Very simple to convert your unnormalized form of data into first normal form. Clear friends? Any doubts you can chat with me in the chat box. So what do we understand? The multi-values are the another important factor which are trying to generate the redundancy. Where is the redundancy friends? Look at A1. A1 is repeated, A1 is repeated, A1 is repeated. Here B1, here B1, here B2, here B2. Here C1, here C1, here C2 and here C2. So you will find some duplicity of data individually. So I will show you in the next pages when you convert multi-values to single values, what is the important step you have to take. It's not directly to manipulate multi-values to single values like this. You're supposed to change your key also. So key is going to be composite in that case, that we will learn slowly one after another lectures. So right now there are two important factors are there to provide the redundancy of data. One is a functional dependency, the other one multi-value dependency, as how A1 is going to generated for multiple pair of values with B as well as C. Okay friends. Now let us take another example. I am saying for example R with X, Y, Z. I am saying X is a key column for us, and here I am saying Y and Z are multi-valued. Therefore, obviously you will find it. What is that? 100% chances of what? Redundancy. Simple answer you can give. Because the X will be having Y and Z combination, so that X value is going to be repeated every time. This is one of the reason for cause of generation of redundancy. In the same way, I already spoke. What is that? If there is a relation R which is having X, Y, Z, if I would like to prove X tends to Y, there may be a chance of redundancy here also, because for every LHS value, we want to generate RHS value. Therefore, friends, FD is one of the factor to give you the redundancy, and MVD, multi-value dependencies, are one of the another factor to generate what? Redundancy. Okay friends, now let us move to next. So redundancy due to functional dependencies. We know, I say let alpha implies beta. I want to prove it in a relation R. Therefore what happened? To prove this, For every pair of alpha values, beta value is supposed to be dependent. So if I am saying alpha 1, if I am saying alpha 2, if I am saying alpha 1, if I am saying alpha 1, if I am saying alpha 1, you could guess what are the values of the beta 1. If I attach the first value is a B10, beta 10, wherever alpha 1 is coming, then you have to raise your beta 10. So I am raising here beta 10, duplicity, beta 10 and duplicity, beta 10 and duplicity. This value is up to you how much you want to keep. But remember, whenever I generate alpha 2, then you have to generate beta 20 as to prove the concept of functional dependencies. This is one of the example why the redundancy is coming because of functional dependencies. Now we have redundancy due to multi-value dependencies. I will write, friends. Once again, look at this. Multi-value is represented like this. Functional dependency is represented using a single, and multi-value is represented using double arrow. What is a multi-value? We will see at the end of the normalization class. But right now we will understand how does it give you multi-value dependencies, right? For example, I say there is student relation which consists of student number and student name and course. Observe, friends, student number S1, name is something like Banu, and the course is something like C. He may eligible for C++. He may also take Java. Now you can guess if I am keeping one more, if I am keeping a one more, that is mobile number, phone number, then this phone number also can be like this. So you can have multiple phone numbers like this. Therefore, what happened? This this course is a multi-valued attribute. This phone number is a multi-valued attribute. So 100% because of this multi-valued attributes, it is going to give you a redundancy which I shown you in the previous page. What is that? You will see that S1 is coming in a multiple combinations. S1 Banu for C you will get, and C with the first number, C with the second number. So his record is repeated twice up to this instance. Again, S1 Banu is appearing for C++, this number and this number. Again, S1 Banu, it appears for Java and this number and this number. That's it, friends. This is how the multi-valued columns are generating redundancy in the table. Okay, friends. So, two important factors which are causing redundancy is functional dependency and multi-valued dependency. Okay. Now, what are the problems which are caused by redundancy? Mainly duplicity of data. We know very dangerous duplicity of data. And number two, anomalies problems. So you will get different anomalies like insertion, updation, and deletion. You will find insertion anomaly. You will find deletion anomaly. You will also find updation anomaly. So what is insertion anomaly? We may not insert the data accurately. This is the meaning of insertion anomaly. Deletion anomaly, it is not possible to delete data, then this is called deletion anomaly. Updation means as there are multiple number of duplicates are there, you have to modify each and every duplicate value. This is a updation anomaly. How does it affect? We will see with one example. So listen, friends, there is a student table which are having a different columns like student ID is there and student name is there, course ID is there, course name is there, faculty ID is there, faculty name is there, and the salary is also mentioned. Now I am writing a value here. Student number 1, name is A, course is C1, and course name is a C, faculty name F1, faculty name X, and salary is 5000. Now observe friends, S2, when I am repeating new column, new value into SID column, then I can give any name to S name. But E is also appearing for course 1 only. You have to understand carefully friends. Whenever the C1 is repeated, please observe carefully. Whenever C1 is repeated, then course name is implying that. Please understand, there is a bound relation between CID and C name. Again, the student 3, he admitted, he joined for C2, the C2 is mentioned with C++, and student 4, he admitted for C1, and whenever, please understand, whenever C1 is repeated, again you have to repeat the value C here. And I have written X, why? What for X I have written? I will show you, observe carefully. And the X and the C3 and Java, some numbers are given. Now we will understand FID. S1 joined for C1, the course name is a C, and the faculty who is teaching that subject is F1. The faculty name is X, he is earning salary 5000. Now this is the problematic for it. This is the problematic for us. Why? See, observe carefully. When I raise a C1, C is repeating. As C is repeating, faculty is the same, so it is repeated. Please observe, it is repeated there and here, and name is also repeated there and here, and his salary is also repeated there and here. The same is happened once again here. Please observe. So C1 is repeated, so course name is repeated, faculty name is repeated, and faculty ID is also repeated, and salary is also repeated. Therefore, what do we understand friends? So there are some functional dependencies which are bound in this student relation. What are the functional dependencies which are bound in this student table? Please observe carefully. Number 1, I am saying SID is the key column for us. Let me take the assumption. Let SID is the key. It's a very typical concept to understand. Watch it, patient. Then you will get this. Why we are maintaining these kind of databases and how they are being decomposed into various sub-relations. Observe carefully. Now here, I am identifying student ID is the key. Therefore, I cannot enter nulls. So whenever I say that it is a key, we know that nulls are not possible, and we know that duplicates are not possible in that. If I am taking this SID is the primary key. Please observe. Therefore, I have data to enter, course data I have, and course name also have, faculty details also I am having, but I cannot enter the data. Please observe. I cannot enter CID data, CNAME data, FID data, FNAME data, salary data unless and until I know the value for what? SID. Why? Because these are all the columns are depending on your key column. Because here I said that SID is a primary key means the primary key implies, as I am saying here, as SID is your key, then SID implies your R, as they are all single valued columns. Therefore, you will get many functional dependencies like SID implies a SNAME, and SID implies a CID, and SID implies a CNAME, and SID implies FID and FNAME, as well as SID also implies salary. Therefore, what the primary key is saying, you cannot enter nulls, you cannot enter duplicates. Therefore, you want to enter this data. What is required? There is a mandatory to enter data into which column? SID column, as SID must not be nulls. If you leave it blank there, then you cannot enter data for the remaining columns. This is the concept of what? Insertion anomaly. What is the insertion anomaly? Unless and until you enter the data for SID, you cannot enter data for what? Other columns. Therefore, we 100% say that to enter data in these columns, what you supposed to do is you supposed to give some dummy data in that. So I am entering some dummy data. This is also dummy data. Therefore, I can give values for rest of the columns. That means, what is the insertion anomaly? You want to enter data in other columns. You supposed to enter dummy data into primary key column because primary key will not accept nulls. So enter dummy data, then you follow the data for a remaining column. This is insertion anomaly. Okay, friends, what is a deletion anomaly? Observe carefully. If I delete S1, please observe. If I delete this S1 here, first row, then S1 is deleted. Then when I delete, you are going to find blank values. So if I leave the blank values, it will give you error that blank values must not be. Therefore, when I delete S1, this complete record you need to eliminate it. That is S1A. When I am deleting this student, then C1 will be deleted and C will be deleted. F1 X 5000 will be deleted. So what is the meaning of deletion anomaly? If you delete value in one particular attribute and remaining values will be disturbed. This is what is the meaning of deletion anomaly. What is updation anomaly, friends? Multiple copies of updation you supposed to do. For example, I want to update the faculty one salary to 10,000. Then you have to erase 5,000 and write 10,000 there. Here also 10,000 there. In this also you have to write 10,000. Therefore, this 5,000 will be vanished. You will get a new value 10. This is also 5,000 will be eliminated and you will get 10,000 values. So three important anomalies we discussed because of redundancy. One important, you have to enter dummy data in the primary key column to enter the data into other columns. Number two, updations. What is updation? As many duplicate data is there, you have to overwrite on the duplicate data with the new values. I want to update this F1 salary from 5,000 to 10,000. Then multiple times, 3 times you have to do updation. This is the problem. And number three is deletion anomaly. Since all these remaining columns are depending on SID, as and when you delete some student, then entire tuple will be deleted. Therefore, we are losing other particular attributes data. This is what is the meaning of deletion anomaly. Okay, friends. Now see, from the previous table, it is holding some of the functional dependencies. First functional dependency we all know. What is that? As SID is a key, it implies other attributes. It implies name, CID, it implies CNAME, FID, FNAME and salary. Apart from that, there are other functional dependencies are also bound there. What are that? We will observe. Look at friends. See here, whenever CID is repeated, C1 is repeated, so CNAME is coming. Whenever C1 is repeated, CNAME is coming. Therefore, the other functional dependency is CID to CNAME. Reverse also true. Whenever C is repeating, C1 is appearing. So CID bidirectionally implies to CNAME. And other functional dependency is also there. Observe carefully. Whenever CID is repeating, then faculty ID is repeating and faculty name is also repeating and salary also repeating. Therefore, CID implies name, FID, FNAME and salary too. Another dependency is there. What is that? Whenever F1 is repeated, X value, the faculty name is repeated, and the faculty salary also will be repeated. This is another dependency. So we want to highlight what are the dependencies are hold on the given student relation. Let us look at, as I tested, you also test like that. So these are the dependencies, friends. Many other may be implied bidirectionally, but I am writing main important functional dependencies. So CID implies CNAME, CID faculty. Whenever CID is changing, faculty ID is changing, faculty name is also repeating, salary is also repeating. Whenever faculty ID is repeating, faculty name is duplicated, salary is duplicated. Whenever faculty name is duplicated, salary is also duplicated. Clear, friends? So, but there are two other functional dependencies are there. CID and FID are not deriving SID. Why? We will see. Please observe, friends. CID is not giving SID, and one more, FID is not giving SID. We will cross check. How does it happen? Come to the previous. CID is not implying SID. What is CID? C1. What is SID? S1. So whenever C1 is coming, what has to come? S1 has to come, but S2 is given. Therefore, it's a failed dependency. Just they are the two examples. Maybe others also maybe existed. I'm telling you some are existed, some are not existed. And one more, FID is not implying SID. Why? F1, the bound name of the student is S1, but whenever I call F1, it may not exist. Why? Because a faculty may teach to multiple number of students. That's why it is not realistically true. In order to prove that FID to SID, it's highly impossible to repeat the same student n number of times. Therefore, friends, as far as this concern, these are the dependencies you could derive from the previous table, that is student. So what are the problems with the student table? Three anomalies I said. Unable to insert. So you want to insert other columns data, send dummy data into primary key, so that insertion problem will be cleared. Deletion anomaly. If I delete one student, entire record is deleted. Updation anomaly. So multiple times updations is supposed to do. Okay, friends. Now see. So the problem which I spoke are mentioned here. The student table suffering from three anomalies: insertion, updation, and deletion. What is insertion anomaly? What is insertion anomaly? Insertion anomaly is like this. Unless SID data is available, unless SID data is available, what is the problem? We cannot insert data into student table for other attributes. So that's why what you supposed to do here, what is the remedy I said? The remedy to clear this insertion problem is that add some dummy data. Add its dummy data into SID, then you proceed to enter the data into other attributes. Then enter data into other attributes. Okay, friends. Later on, we will change that particular dummy data and enter the accurate actual data. But right now, we will come out from insertion anomaly just by doing what? Entering dummy data in that. Now what is the deletion anomaly? I said we are all completely depends on SID only. As SID implies, please observe, as SID is a primary key, then SID implies the remaining attributes of your R. Therefore, if we delete any student data, and my target is SID, then what will happen? Other attributes data will be deleted. Other attributes data will also be deleted. Why it is deleted? Because other columns are bound on SID. Other columns are bound on student ID. We are all depending on student ID. Therefore, when you delete some student number, it automatically delete other tuples as SID must not be null. This is the important point. So in order to see that SID must not be null, so delete entire tuple. So we lose the data of other attributes. There is a data loss in that. So this is a deletion problem. What is the multiplication, that is updation problem, we will see now. So the third anomaly is updation anomaly. Friends, what is updation anomaly? Multiple times, multiple edits required whenever any updations required, whenever any changes required. Therefore, what happened? Let me give you S1 and S1 and S1 and S1. 4 times S1 is repeated. Student number you guess. For example, this is student number column, this data, and this is address column. So initially he has given one address, like the address name is A1. So as and when S1 is repeated, address is going to be repeated. He belongs to this address only. If address got changed from A1 to A2, you assume, let me write that. If address need change, from A1 to A2 of S1, then how many times you have to do that updation? As many A1s are there. So therefore, this you need to update to A2, this you need to update to A2, this you need to update to A2, this you need to update to A2. As and when S1 is there, those many times updation required. This is the time complexity to manipulate multiple number of edits or changes or updations. Okay, friends. So to avoid these anomalies, which are coming from your redundancy, there is a need of what? Decomposition. So what I am doing? I am doing a decomposition of student table, because if you maintain the single table, then there are some duplications you are finding, and insertion, updation and deletion anomalies we found. Hence I am splitting into 2 or more subrelation. I already taught decomposition lecture in earlier of my YouTube lecture. Please follow how we do decomposition, right? So I am splitting the single table into double table. So the student table is split into student and the other information is there. So we just keep a heading of the table as course. Now student is separated from your course table. Hence, what will happen? Your student, please observe your original student table. So this is your original student table, consists of SID, S name, CID, C name, FID, F name, salary. So I am segregating student information from course and faculty information. Therefore, SID, S name will be divided, remaining will be other subrelation. So we got two tables, student ID I separated, and course information and faculty information I separated. Okay friends, now let us understand, whenever you do decomposition, please observe carefully, whenever you do decomposition there is a requirement of common attribute. This is a mandatory to prove your decomposition to lossless join and dependency preservation and attribute preservation. So decomposition follows three important properties: attribute preservation, lossless join, dependency preservation. So I'm taking a common column to prove that the decomposition what I did into two subrelation is the best. So I'm taking, this is your primary key here. So which do not have duplicates there. Please observe friends. As I am making that is a primary key, the primary key implies student name obviously, therefore your key is implying all other attributes. Forget about CID right now. Now rest of the columns I have divided from your original student table. So CID brought into this, name, FID, F name, salary is being segregated from your first table student. So I post the data C1, C2 and C3. So why I post only unique tuples? This is the magic of decomposition. What is that? See, earlier it has got redundancy in some of the columns. So CID has got duplicity C1, C1, C2, C1, C3, and CNAME is also got duplicity. FID is also got duplicity. FNAME also got duplicity. Salary also got duplicity. But this time we will eliminate that duplicity. How? Please listen. So we will write only three rows. Please observe. Course 1, name is C, taught by F1, name is X, salary is 5,000. We will not repeat once again course 1 because course 1 we want to record only one time, as this data is separated from your student data. Now course 2 C++, faculty is F2, faculty name is Y and salary is 10,000. C3 Java, faculty 3 Z and 15,000 friends. Now what I want to do, I want to join this table with this table. So this is a natural join which we are doing already. We learned in the decomposition topic. So natural join requires common column. So what is a common column? So this CID I want to use it as here for NK. Therefore you observe carefully friends here. I am merging the student table with the course table. Therefore data is not going to be lost. That's very important. So let me do. Student 1 join for course 1. There also you will find same. Student 2 join for course 1. You want to see, just let us have a look at there. Student 1 join for C1. Student 2 join for C1. Student 3 join for C2. And student 4 join for C1. This is how. So let us see that I am merging like that only. Student 1 join for C1, 2 join for this, 3 join for this, 4 join for this. So after joining, you may know that what is the course taken by S1. Student 1 took the course C1. What is a C1? C language. So I am combining. This C1 will be combined here. So C1 taught by C. That means S1 took course name C and faculty F1, his name is X, he is earning 5,000 salary. So therefore, friends, this is how you can able to merge the data. And S1, S2, this time he obtained C1 course, you can map there. So after merging, you will get the original table of student only. So from this decomposition, we have eliminated some of the anomalies. There we found three anomalies. Insertion, unable to enter the data for remaining course and faculty data. Deletion, if student deleted, entire data will be deleted from course. And what else? Multiplication updations you supposed to do in the event of change of what? Salaries. But they are not here. Why? I can enter student data. For example, C4 I want. You can enter C4. Let me enter. So I can enter C4 here. Course is something like .NET. Faculty is a F4. Name is A. And salary is 20,000. You can enter happily. It doesn't require any kind of support of student. But earlier it is not like that. You want to insert course and faculty data. There is a need of SID. Therefore, we are using dummy data for S number. But here it is eliminated. What about updation? I have only unique salaries, so I will update only one time. Therefore, multiple updation is also solved. What about deletion? If student left from the particular organization, you can delete the student data. I don't mind. It doesn't affect to your other table data. I have got course data, faculty data, 5,000 safely in an instance called course. But here I could happily delete what? Student record. That's it, friends. This is how you could able to avoid anomalies which are coming from redundancy. The avoidance of redundancy is done only using a what? A decomposition concept. Okay, friends. So finally, we understand no insertion anomaly, no deletion anomaly, and no updation anomaly as far as student table concerned. But still, there are some problems in the course table. Why? You observe carefully. As I said that course ID I am making as a key, all other course table attributes depends on course ID only. Therefore, all three are applicable here. So these three are cleared from the student, but these three are affected onto course table. How? I want to enter faculty details. It's not possible. Unless you enter the course ID dummy value, you cannot enter faculty data. First insertion problem. Deletion problem. If I delete any course, then automatically faculty data will be lost. That is a deletion problem. And updation problem. If there are any multiple copies of data is available, then you have to do multiple copies of data. So still, they are suffering. We are suffering here. Insertion anomaly and deletion anomaly and updation anomaly may be. Therefore, what is the magic to do? So to avoid this redundancy, this course will be subdivided into two more tables. Therefore, you don't find the concept of redundancy or the concept of anomalies even in course table 2. Therefore, let me write why course is having anomalies. As far as course table concern, insertion anomaly I am talking. What is that? We cannot enter data in faculty unless course ID data is available. This is the point number 1. And point number 2, deletion anomaly. Still, it is existed in course. I am talking as far as course. There are no problems as far as student concerned. We are talking about course only. If we delete any course data, then we lose faculty data. Therefore, data loss in that. And the third anomaly is existed, that is updation anomaly. What is that? Multiple copies of updates required. Therefore, friends, what are we going to do? We split the course into multiple instances. That is the theorem. What is that? Course will be decomposed into course ID, course name. Please observe, friends. And the faculty data is separated from there. Faculty ID, faculty name, and salary. I am separated from your course. Now observe, friends. 3 different instances we got. Student number, student name in student instance, course ID, course name in course instance, faculty ID, faculty name, and salary in faculty instance. 3 different subtables we are maintaining. Therefore, you don't find any redundancy of data. Hence, we do not have insertion anomaly, updation anomaly, and deletion anomaly. So, this decomposition I am showing you here. So, how we deleted anomalies, insertion, updation from your student as I spoke, but still the course table is suffering from insertion, updation, and deletion anomalies. So, to avoid those problems, there is a requirement of what? Decomposition. So, after decomposition of your course, please observe. So, we got separate course instance, and faculty is subtracted from your course table, and student is subtracted from your both the tables. I am maintaining student ID, student name, course ID, course name, faculty ID, and faculty name. Same, without redundancy, I am writing in your master instances. That's it, friends. So we understand this is the node. After decomposition, anomalies are removed from your course table. You can happily do insertion without depending on others. You can do insertion anomaly is cleared in this, and updation anomaly is cleared in this, deletion anomaly is cleared in this, because they are independent instances now. They are not mutually depends on others. And student insertion anomaly is cleared here, updation anomaly is cleared here, deletion anomaly is cleared here. Here also insertion anomaly is cleared here, updation anomaly is cleared here, deletion anomaly is cleared here. But I want transaction table for that. So what I am doing, this SID I am using as a foreign key to doing what kind of courses, who is the faculty of the student, that information I am providing in student child table. So this CID I am using as here foreign key. This FID I am using as a what? Foreign key. So they are going to act as a foreign keys. Therefore, you will get the same S1 joined for C1. What is the C1? Compare there. So C1, C1 joined for what? C language. S1, teacher is F1. Who is F1? So faculty name is how much? X, and you want to write salary, you can also write. So some value you will get. S2 joined for C1. What is the C1 course name? So map this C1 with C1, you will get the C language. So who is the faculty? F1. Go there and map F1. You will get what? X. So this is how, without loss of data, we just maintaining 3 different master instances like faculty, course and student, we are trying to do transaction with them using foreign keys. That's it, friends. This is how you can able to avoid redundancy just by doing decomposition concept, right? Now, what is the idea of a normalization? So when you do decomposition in order to avoid the redundancy and in order to avoid insertion problem, updation problem and deletion problem, we are decomposing. The decomposition we are doing only using the rules of what? Normalization. So normalization is trying to avoid the redundancy and anomalies like insertion, deletion and updation by using the mechanism called decomposition. So normalization is a step-by-step process with a set of rules. It's a step-by-step process. It will show you that how you could able to decompose the relations into sub-relations to avoid redundancy and anomalies. It also saying that how normalization describes redundancy is reduced. That is also responsibility of normalization. Friends, when you talk about the redundancy, two causes, functional dependency and multi-value dependencies. And these using functional dependency and multi-value dependency, we are going to get insertion, updation and deletion problems. So to avoid that redundancy, then there is a need of decomposition. The decomposition is only can be done using a set of rules. The rules are provided by your normalization. So finally, what do we understand, friends? When you do normalization, it will tell you how you are going to decompose. So decomposition it will tell. Once you do the decomposition, then you are going to avoid what is that? Redundancy. So redundancy can be avoided using the concept of decomposition. What are the problems of redundancy? If you avoid the redundancy, you will prove that no insertion anomaly, you will prove that no deletion anomaly, you will prove that no updation anomaly. So friends, this is what is the main objective or motto of normalization. Normalization will tell you how to decompose your table to avoid the redundancy and further to avoid anomalies. I will tell you another example. Look at carefully. So I'm taking generalized instance now. There is a R. Please observe. With some columns like this. Five columns by name A, B, C, D, E. I'm having data. Let I'm saying A is the primary key in this. I have data A1, B1, C1, D1, E1. It's done. Now I'm repeating A1 here. When you repeat A1, B1 should come, C1 should come, D1 should come, E1 should come. But it is not true. Why? As I am making this A is a primary key, I cannot give what? Duplicates. So therefore, you have to take a different tuple over here in order to map this row. Okay. Now I am following the principles of primary key A3. No problem. You can repeat them. B1, C1, D1, E1. So as I am making that A is a primary key, so I am not going to have any concept of duplicates. We all agreed. But there is a problem. What is the problem here? Some of the dependencies are giving you redundancy. What are they? B1, 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 hence C1, 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 D1, 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 E1 is also repeating. So what to do? You're trying to split the table. How are you trying to split the table? So I'm splitting the R1 with AB if I am taking assumption, and R2 I am taking common column there and here A, C, D, E. Okay friends. Therefore what happened? Your data is unique here. Observe carefully. A1, B1 here, and A2, B1 here, and A3, B1 here. So we understand this is your key. Now here I am taking some tuple set by using this A primary key. I am keeping this as a foreign key. Now I can repeat A1 any number of times you want. You can go for repeat. I am taking a B1 and B2 and B3. Okay friends. So as this is a C column, so we will fill. So we will fill C data. Now C data is presenting like this: C1, C2, C3, and D data is presenting like this: so there is a C column. Now I'm taking a D column here. D1, you can give D2, you can give D3, and you have E column here. You can have E1, you can have E2, and you can have E3. But still there are some kind of a duplication if you find in this, and this is further decomposed. How it further decomposed? I am decomposing into, this is R2, I am decomposing into R3. So I am decomposing like this, CD, and I am decomposing like this, DE. Now we got finally three tables, namely R with A, B, C, D, E split into R1, AB, and R2, BC, and R3, CD. If you want, you can extend, and R4, you can go for D, like this. So based on the nature of the table, you try to decompose, friends. For example, there is an employee table I am maintaining. So employee number, I am mixing all the data here. Employee number, employee name, employee job, department number, department name. So I am mixing two kinds of information in this. So E1 I am making as a primary key. So duplicates not possible. Name X, Y, Z. I am following perfectly for employee data. You understand job, clerk, clerk, and manager. So clerk employee 1 is working in 10 department. 10 department name is a sales, and he is working in 20 department. 20 department is accounts, and 30 department it is operations. See friends, there are some anomalies here. What are the anomalies? Insertion, updation, deletion. What is insertion anomaly? We cannot enter department data without employee number, as all these four columns are completely depends on your employee number only. Okay, now what is updation? So here it doesn't require updation anomaly. I am writing as not applicable, as there are no duplicates data. Or you want to raise a query, you can raise. I want to change clerk to some other designation, so you have to do twice. That's you can do. And deletion anomaly is very important. If any employee left, if any employee left from the organization, if any employee left from organization, then what you supposed to do? We delete that employee. So when you delete that employee, we lose department data. So we got loss of department data. So in order to avoid these problems, so just to separate into two different instances, one is purely employee, another one is purely department. So now your employee table, the 5 columns table will split into two different instances. Your employee table split into two instances. One is a department table, which is of department number and department name. I am making this is to key, and the other table is employee table. I am making employee number, employee name, and employee job. You will get the same data here and there. What is the data? So E1, E2, E3, CL, CL, MA, E1, E2, E3, clerk, clerk, and manager. So this is a job column, and this is employee name column by name X, Y, and Z. Now department table as it is separated. Now this is the key for us. So 10 department, 20 department, 30 department. This is sales and accounts. Whatever you want, you can write here as it is independent table operations. Okay friends, but you observe carefully. I want to make this decomposition to lossless join. That means we want to prove every time what? Best decomposition. So you want every time best decomposition. You see that there is a requirement of common column. So what I am going to do? This department number I am using as a foreign key here. So friends, Employee number 1, let us look at the data. 10, 20, 30, they are working. He is working in 10, he is working in 20, he is working in 30. Now see, employee 1 clerk X working in 10. 10 is nothing but sales. And employee 2 working in 20. 20 is nothing but accounts. So we will get 100% what? Best decomposition. So how the anomalies are cleared? In the earlier, there are 3 anomalies are existed, and now those 3 anomalies are cleared. Insertion anomaly is cleared, updation anomaly is cleared, deletion anomaly is cleared. I can enter department data on its my own. I am not depending on employee data. And in employee also, you can insertion anomaly, we have cleared all the anomalies. And deletion anomaly we have cleared, and updation anomaly also we have cleared. So here also we cleared all the anomalies. This is how to do decomposition, friends. But while you are doing decomposition, you have to depends on normalization. So let us give a recap. The problem with redundancy is nothing but duplicity of the data. When you have duplicity of the data, there is a concept of inconsistency. The inconsistency leads to insertion anomaly, updation anomaly, and deletion anomaly. So to avoid those problems, first break redundancy. How to do that? Use the normalization techniques and do the decomposition. So from the decomposition, we try to clear redundancy. When you clear the redundancy, then there is no concept of insertion, updation, and deletion anomalies. So friends, I want to give you finally one important point. What is that? So I said, when you have the redundancy, which is causing from functional dependencies, this is very, very dangerous. Where are you going to control? In first normal form, some redundancy can be eliminated. Some redundancy is eliminated, but it's not completely free. Please observe. Very important questions. And when you come to the second normal form, the redundancy is less than your first normal form. Therefore, some more redundancy is reduced. Some more redundancy eliminated. And you have another one, third stage. Here redundancy is less than first normal form and the second normal form. Therefore, redundancy is almost all eliminated. So some more redundancy eliminated. When you come to BCNF, please observe friends, not completely free from redundancy. Please follow, that is very, very important point. As I said, FD will give you redundancy, and we are going to break that redundancy in different stages. So 2NF is also not completely free from redundancy, but it is somewhat lesser than the previous. 3NF is also not completely free from redundancy, but it is somewhat better than the previous. But once you come to the BCNF, the redundancy, this is a very, very important question in real time. The redundancy is fully eliminated. Therefore, redundancy is how much, friends? 0. So in BCNF, the redundancy is 0. That means starts with a high redundancy and it comes to the finally 0 redundancy. That is the concept of normalization. So normalization provides a step-by-step process and a set of rules to decompose the table so that the redundant table will become non-redundant table. So BCNF, the redundancy is how much, friends? It's a very simple to answer. That is what? High redundant is nullified and you will feel that there will not be any kind of duplicity. That's why normalization plays a very important role in the real-time database design. So friends, BCNF, almost all controls, 3NF, still it is existed, 2NF, still it is existed, 1NF, still it is existed. But somehow they are able to control the redundancy, but they are not completely free. But when you come to the BCNF, then you will see that the redundancy is almost all done. Okay, friends? So BCNF is telling you that you don't have the concept of redundancy in this. Well, friends, so we'll end today's lecture, the very important lecture, which is the first step for the next upcoming lectures. What is that? Redundancy, nothing but duplicity. The causes of duplicity, functional dependencies and multi-value dependencies. And the functional dependency generation, redundancy can be controlled in 1 and 2 and 3 normal form, but they are not completely redundant. Even in 1 you will find duplicity, 2 also you will find duplicity, 3 also you will find duplicity. But when you reach to the last level, that is BCNF, your redundancy becomes 0. So, and what are the issues of the redundancy? There may be a chance of insertion anomaly and updation anomaly and a deletion anomaly. So to avoid those anomalies, break the redundancy using the decomposition rule with the help of normalization rules. So therefore, we will feel that there will not be any kind of anomalies due to non-redundant of data. That's it, friends. Stay tuned to our YouTube lectures as well as special classes of Unacademy. Stay tuned to Unacademy. Subscribe to us. Use my promo code to get the 10% off. Join in my Telegram. My Telegram number is 8790 and 520520. Subscribe to us for latest modifications and updations. Our anthem is Let's Crack GATE CSE through Unacademy. Stay tuned to us. Thank you very much.